Procession is where the direction of the axis of the magnetic moment rotates about an axis that's parallel to an external magnetic field. So if the magnetic field is in this direction, the axis of the magnetic moment is in this direction. This axis rotates around about that axis of the magnetic field. The other end also rotates. As you can see in the diagrams here, it's the same. The motion's similar to a spinning top with its axis of rotation tilted a little bit to the vertical or to gravity acting straight down. And it's that motion about the axis, a little bit like a wobble, and it's a consequence of the law of angular momentum. The frequency that it precesses with is called the Lamour frequency, so the amount of rotations around that axis per second, and it's typically around 85.2 for a 2 Tesla magnetic field, and that's megahertz, so 85.2 million hertz per second, and that corresponds to a particular radio frequency. The Lamour frequency depends on the composition of the nucleus. So if we go to the next, seen already, this is what it would look like were there no magnetic field. If we have a look at the next slide, this is what it would look like if there was no precession. But here we have precession around the Earth's gravitational field. So you can see the axis is rotating around that. And you can see that you could work out the frequency that happens. The other end is also rotating. So you're getting that movement around that particular. And that particular frequency that happens is the Lamour frequency. Lamour frequency depends on two things: the composition of the nucleus, so the number of particles in the nucleus, in particular the number of unpaired spins, or net spin of the nucleus. But you can have, say in this case we've got 1, 2, 3, 4, 5, 6 paired nuclear particles and one unpaired. In the next slide we'll see a few different examples with different nuclear composition, and you see a change in frequency. The other thing is the strength of the magnetic field. So altering the magnetic field will change the Lamour frequency, the frequency that this precession occurs at. And we saw the average is about 85 megahertz for hydrogen. And here's the next slide, and you can see there, depending on the nucleus of these atoms, the spin is slightly different in two cases, but the frequency changes considerably, the Lamour frequency, and that's in a particular strength of magnetic field. Increasing the magnetic field also changes the frequency. Okay, so two things: magnetic field strength, or Teslas, and the composition of the nucleus, the number of nuclear particles present. to the Lamore frequency, or the frequency that these protons and neutrons process at.